Okay, so as in the last video we have calculated the electric flux due to a point charge which we have placed at the center of the circle. Alright, in today's video we're going to talk about the potential difference in very detail with a lot of MCQs which will be very important. Alright, so today what is our topic? That is potential difference. Potential difference. Initially I'll be telling you what it is, then I'm gonna tell you about its nature as well. Alright, so in today's video we'll just gonna discuss or we'll understand the concept of this potential difference, and we're gonna drive its unit. Not today, however, that we'll be driving tomorrow, but in today's video we will gonna see the formula of the potential difference, what it is equal to, or how we can represent that in the mathematical form. Alright, so initially we will be going with the term potential difference, since we have to understand the concept of it, what it is. Alright, so basically suppose if you have a charge here, and this is a source charge, Another name of source charge is point charge or point charge. These are the charge which basically generate the electric line of force. So why this is termed as source charge? Since it is the source for the electric line of force, that's why it is known as source charge, or we can say it is point charge as well. Alright, so now here we have another charge which is placed at the lower potential. We'll be discussing about that as well. Alright, so now I have to take this charge, for suppose this has a positive charge and this is a positive charge too. Now I know that if I am gonna bring this charge here, this charge will gonna put more repulsion in it. It will not gonna take this inside it. So the work done in bringing 1 coulomb of charge inside the electric field is what we call the potential difference. The work done in moving 1 coulomb of charge from higher potential to the lower potential, which means from positive terminal to the negative terminal in an electric field, that is what we call the potential difference. So now let me write the definition here so that it can be more clear to you. Alright, it is nothing but it is the work done in moving 1 coulomb of charge, 1 coulomb of charge from higher potential, or you can say from positive terminal. I am writing here higher potential, here mentioning positive terminal as well, to the from higher potential to the lower potential, or to the negative terminal in an electric field, is what we call the potential difference. So this is the basic concept of it. What is potential difference? The work done in moving 1 coulomb of charge from higher potential to the lower potential, which means from positive terminal to the negative terminal in an electric field, is what we call the potential difference. Alright, or you can say it is work done per unit charge. The second definition of it, or in other words, it is work done per unit charge, per unit charge when a test charge is moved from lower potential. This is the test charge. Alright, this is the test charge or unit positive charge. So here again you have got 4 more MCQs. Alright, test charge or unit positive charge. Positive charge, test charge or unit positive charge. Alright, so work done per unit charge, when a test charge is moved from lower potential to the higher potential against the electric field. You can see electric field lines are like this, but they are moving against the electric field intensity or against the electric field. The work is stored in this charge. The work will be stored in this charge in the form of electrostatic potential energy. Very important in terms of MCQs. Alright, so I'm writing here. Sorry, I need to use this. Alright, very important. This topic is very important in terms of MCQs. So second definition we have got. Alright, wait, I'm gonna read for you again. Let me highlight this. So it is nothing but it is work done per unit charge when a test charge Q naught is moved from lower potential to the higher potential, that too against the electric field. Then the work is stored in this test charge. The work is stored in this test charge in the form of what? In the form of electrostatic potential energy. If I do write this in the mathematical form, how will I write that? Wait, let me write that in the mathematical form now. So mathematically, as I initially told you, it is work done per unit charge and potential difference is denoted by V. Potential difference is denoted by V. Alright, is denoted by V is equal to, is nothing but it is work done per unit charge. It is work done per unit charge. It is work done per unit charge. Alright, now we know that work is equal to what? Work is basically dot product of force and displacement. Here I am going to take del R, which means here it will gonna take only small displacement. So work is a scalar quantity too, since it is the dot product of force and displacement. When we're going to remove this dot between these two quantities, we're going to have cos theta, which will going to show the angle between the force and the del R, which means displacement. Alright, so now let's drive this for, or let's put this formula instead of that equation. Alright, the equation was W upon Q. So V is equal to, instead of W I can write it is the dot product of force and displacement upon Q. So of course Q naught. Alright, now what is force equal to? We have already studied about the electric field. Alright, that was equal to force per unit charge, and I want the value of force. So charge is dividing here, when we go there multiply. So F would be equal to EQ. Alright, so let's put this instead of F2. Alright, so let's put this. So V is equal to, instead of F I can write EQ naught into small del R Q naught. Now see this Q cancel. Alright, so potential difference thus is equal to what? It is the dot product of electric field intensity and the small element or the displacement. Alright, so it is also a dot product, which means it is showing that it is a scalar quantity as well, because we know that when we have a dot product of the two vector quantities, the answer will always be scalar. So potential difference is nothing but it is the dot product of electric field intensity, which is a vector quantity, and the small displacement or del R, which is a vector quantity too. So between the vector quantities we have a dot, and when we're going to resolve it, we're going to have cos theta, that is a function which we will get between these two quantities, which will be showing the angle between the electric field intensity and the displacement. So potential difference is the scalar quantity. This was all for today. In next video, we're gonna drive the unit for the potential difference, and we'll be talking about its nature, what nature it has, and we're gonna have its dimension as well.